Here are some helpful FRQs, free response questions for an AP chemistry class studying atomic theory. It's very important to be able to discuss different ideas like nuclear charge, shielding effect, energy levels, distance from the nucleus, and how that all relates to one another. You should be able to write and answer all these questions within 2 to 3 sentences. Strong suggestion is to always lay out what the situation is first. So you identify where the electrons are or what energy level is present in both or all the atoms that are given to you. Then you should back up the statement with the reasoning of why the information or the data is what it is. So let's take a look at each of these. I strongly suggest that you read it, you pause it, and you actually physically write out your sentences. Do not simply just fly through this video. It will not help. You need to be able to formulate your own ideas and then see if they correlate or they connect with some of the answers that will be given. First one. Within a family such as the alkali metals, the ionic radius increases as the atomic number increases. So please pause it and then come up with 2 to 3 sentences explaining why in any group the ionic radius increases as the atomic number increases. Here's a little visual. Although I understand that it says ionic radius and not atomic radius, this still shows in general what we are looking at. The key thing to the question is that why is this increasing even though the atomic number is increasing? As we move across the table, the atomic number increases, but it actually shrinks. The reason why that is happening is because you're staying in the same energy level and you're increasing your nuclear charge. So as you move down a table, you notice that it's getting larger and larger. So why is that? Simply put, it's increasing energy levels. Again, I know these are atoms and not ions, but we're in the second energy level. Now we gain a third energy level. Now we gain a fourth energy level. The electrons are getting further away, and we're increasing the shielding effect. You notice that they're increasing the shielding effect. An incorrect answer would be talking about the nuclear charge. If you say that the nuclear charge is increasing, the minute you pull that out, you would then probably be talking about how the atom is getting, or the ion is getting smaller. It is not getting smaller, it's getting larger. So you do not want to touch or discuss the nuclear charge in this debate at all. So this is an answer I came up with. It's a little wordy, but it does do the trick. The radii of the alkali metal atoms increase with increasing atomic number because of the increase in energy levels. These levels cause the valence electrons to be further from the nucleus. In addition, with the increase of inner electrons, the shielding effect increases, which causes the valence electron to not be as attracted to the nucleus, which allows it to be at a further distance. Obviously, there are variations in different ways that you can approach that. So this would definitely cover the answer and the items that you need to discuss. Next question. The radius of the chlorine atom is smaller than the radius of the chloride ion, Cl-. And then below they give you 2 values. Please don't be confused about units if you have not ever been given one or recognize it. This is an angstrom. It's 10 to the negative 10th meters. It does not matter. It shows that this is a certain value, and then that is a much larger value, almost doubled. They're trying to say that they're trying to show you how it almost doubles in value. So please take a moment, pause the video, and come up with a reason why you think that the chlorine atom is smaller than the chlorine ion. Here's my visual. Doesn't help you much yet, but we need to understand is the differences between them. Always talk about what each one has. So both of them have the same nuclear charge. They both have 17 protons. When you are talking about an ion, you are gaining or losing electrons. So you have 17 electrons in the atom, but you've gained 18 electrons in the ion. So what does that mean? That means that the nucleus, which is trying to hold those electrons in, is trying to wrap or roll in, keep in 18 electrons instead of 17. So the effective nuclear charge, or the effect that positive attraction to those negative electrons have, is weakened when you add an entirely extra electron. So my answer is, although both have 17 protons, the atom has 17 electrons while the ion has 18. So there's my initial statement saying what each one has. I've laid the table. I've set the groundwork. Now I can discuss what that means. This increases the electron-proton ratio and causes the nuclear charge of the ion to be less effective than the atom. This causes the electrons in the ion to be less attracted to the nucleus, causing the electron cloud to expand. So I'm trying to discuss that although it has the same nuclear charge, those protons can't hold the 18 electrons in as well as the 17. Letter C. The first ionization energy of aluminum is lower than the first ionization energy of magnesium. And again, they show you the values. So removing the electron from magnesium versus removing the electron from aluminum, and it takes less energy. Please pause it and come up with your ideas of why it's easier to remove an electron from aluminum than it is from magnesium. Reminder again, please, lay out the situation. What are we talking about with aluminum versus magnesium before you give your reasoning? What I did first is actually drew a picture to illustrate where I think the electrons are. This isn't a bad thing to do. If you have it on the side, you're still showing the reader where those electrons are, not in words but in picture, but this is not enough. You need to still explain it. So ionization energy is the ability to remove an electron. The further away the electron is, the more shielding, meaning levels between the nucleus and that electron, the easier it is to remove. So you need to understand that just because a 3p and a 3s have the same energy level, it doesn't mean that they are the same distance from the nucleus. So I tried to illustrate with that with my picture. So my 3p is a little further away from the nucleus than my 3s, and because of that I have 2 extra electrons between the nucleus and that electron. My answer I went with then is that the electrons being removed in the magnesium is located in the 3s while the aluminum is in the 3p. So I've established my situation. The 3p electron gains extra shielding from the 3s orbital. Additionally, the 3p orbital is farther from the nucleus, allowing it to be removed easier than the electron in the 3s of magnesium. Again, set up the situation and then get right to the point. Final question. For magnesium, the difference between the second and the third ionization energies is much larger than the difference between the first and the second ionization energies. So what it's saying is removing the third ionization energy is much more difficult than removing the second in comparison from removing the second and the first. And they give you all the values. So you got 7.6, you got 14, and you got 80. So why is it so difficult to remove that third electron? And I'm probably giving more hints than I should already. Give it a shot. Pause it. So what I did for learning purposes is that I created my magnesium orbital diagram, and I color-coded each one. So this is removing the first one, the blue is removing the second, and the red is removing the third. It's saying that this one's that much more difficult to remove. So looking at this, these are my 2 valence electrons. They're the furthest away. They have all this extra shielding from my nucleus. So the further away you are and the more shielding, if it's a valence electron and outer electron, it should be easier to remove. As you remove those electrons, you're getting closer and closer to the nucleus. So removing those first 2 are easy because those are both valence electrons. The last one is more difficult because now you are dealing with a core electron. You are in an extra energy level, and you are that much closer to the nucleus. So the answer I gave is, in a magnesium atom, the first 2 electrons lost are removed from the 3s orbital, whereas the third electron comes from the 2p orbital. A 2p orbital is much lower in energy than the 3s is. So more energy is needed to remove a 2p electron because it is closer to the nucleus and has less shielding than an electron in a 3s orbital. I hope this all helps in your organization on laying it out first, then talking about what you've said to answer the question as directly as possible.